In this video, we're going to take a look at how to solve this LeetCode 88 merge sorted array problem. Let's take a look at the description of this problem. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, which means the given arrays are already sorted in ascending order, and two integers m and n representing the number of elements in nums1 and nums2. Here the m and n gives the total number of elements in nums1 and nums2. Okay, our goal is to merge nums1 and nums2 into a single array sorted in non-decreasing order, which means the final output should also be in ascending order. The final sorted array should not be returned by the function, but instead be stored inside the nums1. We have to update the given nums1 array. We should not return the new array. Okay, to accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements that are set to 0 should be ignored. Nums2 has a length of n. Okay, so the nums1 have already the total number of positions that can accommodate the nums1 plus nums2. Okay, which means we don't need to extend the nums1 to accommodate the nums2 elements when we finally merging the given array. Okay, that's the thing. Okay, let's take a look at this example. Here we can see the nums1 have 1, 2, 3 and 0, 0, 0, and the number of elements 3, which means we will consider 1, 2, 3, and nums2 also have 2, 5, 6, and the total number of elements is 3, and the output will be 1, 2, 2, 3, 5, 6, which means 1, 2 and 2 from here, and 3 from nums1, and 5 and 6. Okay, if you take a look at the example 1, the nums1 have only one item, and the nums2 have 0 items. The final output will also be 1. Same for example 3, nums1 has 0 items, 0 elements, and nums2 have only one item, which means we just have to bring the one value from nums2 to and nums1. That's all. We don't need to do anything else. That's it. Simple. Let's solve this problem. So here I have created a new example with 120 and 100 in nums1 and minus 2, 5 and 6 in nums2. So we try to solve this problem from moving left position to the right position, or from start to end. Okay, so first what we will do is we will take the first items from both nums1 and nums2 and we will compare it. Okay, so here we will compare the 1 and minus 2. If 1 is greater than minus 2, then we will just move the smaller number to the left of the number that we have compared it with nums1. Okay, so here we know minus 2 is smaller than 1, then this minus 2 goes to the starting position of nums1, because as per the problem we have to give the output in ascending order. Okay, we have successfully moved this minus 2 to the starting position of nums1. Okay, then we go into the next item. Okay, so here we are also doing one thing, which is whenever we do the insert operation, okay, we are just moving the items in the nums1 to its next position. Okay, so here the number 1 from 0th index moved to the first index, and the 20 moved to the third index, and the 100 moved to the fourth index. Okay, and so for every insert operation we are doing the shifting operation. Okay, that's one thing. Again, here we are checking this 1 is greater than 5. Okay, 1 is not greater than 5. Okay, and again we move to the next item in the nums2. Here we are checking this 20 is greater than 5. Yes, 20 is greater than 5. Since 5 is a smaller number, we have to move this 5 to the left of 20, and we are inserting this 5 into we are inserting this 5 before the 20, and this 20 goes to its next position. Okay, and under also 100 also goes to its next position. Okay, and that's done. Now now we are checking this 20 with 6. Here we are checking, is 20 greater than 6? Yes, 20 greater than 6, and 6 is a smaller number. Here we move 6 to the left of 20. Okay, once we inserted 6 to the left of 20, and again we will do the shifting operation. This 20 will go to the 5th position, and this 100 will go to the 6th position. Okay, and in the final output we have the sorted numbers. Okay, and also we didn't create a new array. Okay, and that's our problem solved. Okay, but here we have one very big problem, which is whenever we do the insert operation, we are shifting the balance items to its next position. Okay, so here we shifted 1 from 0th index, 20 from first index, and 100 from third index to 1 to second index, 20 to third index, and 100 to fourth index, and this goes on until we sorting all the numbers in both arrays. Okay, so this is one big problem. In order to avoid this problem, and also in order to avoid this unnecessary time complexity, we will try to insert the numbers from backside. Okay, from right side to left side, from last position to first position. So we are going in reverse order. Okay, so here we have the numbers from the problem 1, 2, and 3, and also 2, 5, and 6. Okay, so here what we are going to check is, here we will check, instead of checking the numbers from 0th index to the last index, we will check the values from last index to the first index. Okay, so here we will get the last index value of 3, and also the last index value of 6. So here we are going to check if 3 is greater than 6. No, 3 is not greater than 6. So here what we are going to do is, since we know this is the last and also the greatest number possible in both arrays, we are just inserting it into the last position of nums1. Okay, once we inserted it, then here we are moving. So I would also like to explain these numbers. So here the m2 is nums1 current index position, then n2 n equal to 2 is nums2 the index position, and idx equal to the current inserting position. Okay, so here the current indexing position, since we are going from the last value to the last index to the first index, we are going in reverse order. This index will be the last index position in nums1. Okay, since 5 is the last index, we are inserting this 6 into the 5th index position. Okay, so once we done, then we will again move it to the second position, second last position. Okay, so again here we are checking this 5. This 5 is greater than this 3. Yes, 5 is greater than 3. Again we are inserting, this could be the second largest number possible. We are inserting into the second last position in nums1 here. Okay. Okay, so here we moved 5 from nums2 into 5, nums2 into the nums1. Okay, okay, that's done. Again we are going into the next iteration. So here we are checking this 2 is greater than 3. No, 3 is not, sorry, 2 is not greater than 3. So we will just move this 3 to the right of, we will just move this 3 to its next position, because this 3 is greater than 2, and we know this 2 will come before this 3. Okay, that's why we are moving this 3 to its next position. Okay, so in the next iteration we are checking this 2. This 2 is greater than this 2. No, this 2 is not greater than this 2. This nums2 greater than nums2 2 value is not greater than nums1 2 value. Okay, so since we will just move this 2 value into the third position of nums1, and that's it. So here we are just inserting the items. Okay, here we are not doing any shifting operation. This works good, and also the time complexity also remains log of m plus n. Okay, so here the m is 3, and also the nums2 n is also 3. So it will just take six iterations to do it. Now we will go through the the coding solution of it. Okay, so first we will get the mutable values of m as use size. Here we are using the unsigned size because we are going to use this m in text values. Okay, and same for n, and also the inserting position. The inserting position will be m plus n minus 1. Why? Here we can see our total number of values is 3 plus 3, but 6, and the index position will always be minus 1. So here the index position will be 5. So here the initial value will be 5. Okay, let's iterate. So here what we are going to do is, first we will check whether we have iterated all the elements from nums2. If nums2 index position goes below 0, then we knew we are done with our sorting operation. Why? Because we know the nums1 is also sorted in ascending order as per the problem. The nums2 is also sorted in ascending order as per the problem. We know once we have correctly inserted all the elements into nums1, the remaining elements will also be sorted. Okay, and here we are checking if m is greater than 0, which means the mth index. Here we are making sure when this nums1 index will also not going below 0. Okay, and here we are checking the nums1 last value with nums2 last value. Okay, if nums2 value is smaller than the nums1 value, then what we are doing is we are inserting the smaller number to its left position. If the nums1 last value is greater than the nums2 the last number, then we are inserting it into the last position. Okay, so here what we are doing, we are insert nums1 last position. Okay, and also we are moving into the next index, where since we are going from right to left, we are subtracting it. Nums2 minus 1. Okay, if not, if nums1 value is, just a second, if nums2, okay, if nums2 value is greater than nums1, then we are inserting the nums2 value to its last position. Nums2 minus 1. Okay, and we are moving to the left index position. Okay, so here whenever we do the insert operation, okay, here whenever we do the insert operation, this idx position goes down. We are moving from 5 4 3 to 1 because on every iteration we are inserting the largest number possible to the right side. Okay, and we have to, since we are inserting to the right side of the elements, we have to insert the next iteration elements to the left side of the nums1, and idx minus 1. Oh, sorry, here I have to make this mutable. And I think that's it. Let's run this program and we will see the output. Okay, let's submit this. Okay, now we are good. Okay, that's it. I think if you have any doubts or if you feel it's hard to understand, then let me know. I will try to explain it better in the next videos. Thank you. Bye bye.